So as I said, this is for mathematics N1. So what I want to do with you, as I said, look man, the classes have been happening from Wednesday. So we had a class on Wednesday, we had a class on Thursday, we had a class today. So this is day 3. So what has been guiding this class is this part. Let me just show you. So this is what we have been having, but the good thing is, look, I did record all these videos, so there is a recording of all these videos. So what you're going to have is, I'm going to share the links to you guys of the videos so that you can actually go through them and revise, you know. So that can be also something that you can catch up on what you missed. So we are having, just to make sure that you guys don't miss the lessons again, tomorrow we are having a class, and if I'm not mistaken, it's from 4 p.m. to 6 p.m. That is Saturday and Sunday. It's not the same time like this one, but Saturday and Sunday, it's 4 p.m. till 6 p.m. If I'm missing it out, just check the registration form, or you can send an email if ever you are not actually in that sign up form, which I said you guys must sign up. The dates and everything was clear. So let me just check it myself here, but yeah, let's leave it like that. If it's not, I'll send actually an email just to make it things easy. I'll send an email to say what is the starting time, but just be ready for 4 p.m. till 6 p.m. It's a 2-hour, that is for Saturday and Sunday. So that one we'll be wrapping it up, and I will encourage you from actually part of Saturday, bring in your questions or send me your questions in advance so that I can kind of have a look at them, put them also as part of the slides so that we can work on them together, you know. So since you are also failing to unmute the mic and we communicate with the previous person we were connecting, we were able to even exchange, you know, he was able to unmute. I was with Martin this other day, he was able to talk also, but I don't know, sometimes, you know, this technology thing, we're still learning these things, man. So just send me your questions, or yeah, that would be the best, because there is no other way I can see. Just send a question. You can send it 2 ways on this email, the 24-minute lessons. You can send, write something, take a picture, or yeah, just a clear picture on a phone, or you can use the Instagram. I was telling the students to say, if you want to use Instagram and send me a picture of what you have, use this one. It's Congruency. That is Instagram, you know. For that, I avoid the WhatsApp. Unfortunately, it's a bit private for me. I don't have a business WhatsApp. Okay, so that is that. So try to use this Instagram if ever you want to send a picture, or you can use the email, the info@24minute lessons. So now what has been guiding us is this guy here. So what we did, as I said, we're looking at these where we went on from day 1. We did a recap there, we did that part, it was day 1. We did that on day 2. Day 2 also we went on to do that. Yesterday was unfortunately yesterday we even did that, you know, because it was allowing that part. We ended up doing even graphs. So the videos that I'm saying I'm going to share with you, that is where we are. So from today we are looking at geometry. We're left with geometry, trigonometry, as well as conversions, percentages, and mensuration. I know it says day 4, but what it will do, it will give us, you see, on day 5 I wanted it to be dedicated to questions and answers, Q&A. So now what I will say, please bring in your questions. Actually, it will start from tomorrow. After doing today, I'm covering 2 sessions. It is geometry and trigonometry. As you can see, it was meant for a single session. And then tomorrow I'll do conversions, percentages, and mensuration, part of the lesson. Then the second part of the lesson, I'm going to do the questions here and answers, and then even on day 5 I'll do questions and answers. So I'll encourage you guys to be tuned in. All right, so I'm just going to go through as much as I can. This is what we did 100. We did all this part, we did all this, we were working, these were the exponents, we did all this part on exponents, we did the logarithms, and then we went on to look at equations subject to formula, the distance, time. We did these equations, we did all this part. We went on to look at the graphs. This was for yesterday. We looked at the graphs, we ended up there. So our lesson is beginning here. I hope you are able to see. Just give me a shout again, just raise your hand if you are able to. Thank you that you are part of this. Thank you, man. Look at this. This is geometry, and geometry is let me see what you are saying there. I hope everything is fine on your side. I hope everything is fine. Are you good? Just raise your hand again if you're good. Thank you. All right, so this is it. So we are saying here geometry. It's I just want to look at this part in brief. I'm just going to bring in some content on this part to say what are the different types of angles, the angles in a straight line, the perpendicular lines, parallel lines, angles in a circle, types of triangles, angles in a triangle, and then from there I'll be able now to deal with the activities here. So let's start with the first part. If we're saying different types of angles, the first one, the angle that is common, there is a right angled angle, the 90 degrees. So what you have that. This means it is a 90 degrees. And then you have an angle that is like this, and then because of its size, this angle is called acute. Why? Because it is smaller than 90 degrees. Smaller than 90 degrees. So 90 degrees is our guide, is the middle. So you've got an acute one, and then you have an angle like this. Let me make it actually like this. You find that you have an angle like this, and this particular angle is bigger than 90 degrees. We call it the obtuse angle. All right, so that is greater than 90 degrees. So we have got the acute, we've got the right angle, which is 90 degrees, as well as we have got the obtuse angle. This is just, as I said, to go through with some bit of content in here, and then let us look at the angles now in a straight line. What do we mean? So if I draw a straight line like that, and then I mark an angle here. Remember, when you're marking an angle, it will be like this. This is an angle I'm marking. Now this particular angle, you must know that it is 180 degrees. So angles in a straight line are equal to 180 degrees. So it doesn't matter if I put a line across like this here, dividing this angle. So you will have a part here and you will have a part here. So now if this part is x and this part is y, what you must know, if I add x plus y, you see that I'm forming a straight line. It must give me 180 degrees. These are angles in a straight line. We're going to do some activities of that. So just remember that whenever, it doesn't matter, again, as I said, you can divide it into different parts. I can divide even that line, and then I have an angle there, I have an angle there, I have an angle there. But when I add all these angles, I must get 180 degrees. Then the next part here is perpendicular lines. What does this word perpendicular? Perpendicular means you have a line like this, just to show you. When something is perpendicular, you will have a line horizontal, and then if I bring a straight line like this, and these lines, they meet at 90 degrees, we say that these lines are perpendicular. And usually we refer them, you do this when you're showing that the lines are perpendicular, right? Or some they put at 90 degrees. But the indication that is perpendicular is this angle must be 90 degrees. So those are very important, because if they say two lines which are perpendicular, automatically you must pick up that they want you to have an angle of 90 degrees there. That's the part. Then the next one is parallel lines. What do we mean by parallel lines? These are very unique lines. For example, if I have a line like that, and a line like that. To show that these lines are parallel, you indicate with an arrow. Now these lines, as we say, they are parallel, but they've got something special with them. Look at this. If I draw a line like this, that is cutting through this parallel line, it can be slanted, it can be skewed like this. Now you will come up with three shapes. The first one is the F shape. You will see this F like this. There is an F, and then you will see that part. As you can see, there is the F here, and the F, and the F. So you'll come up with the letter F. The next one that you're going to come up again is the letter what? The letter U. If I do this, and I do this, and I do this, it's like a cup, but I'm going to make it face up, so it will be like this. See that? Right. And then the other one that you're going to come up with is the letter Z. Look at that. Look at that. And look at that. That's the letter Z. There is different types there, but let me start with this one. So that's a Z, or you can have a Z like this, a Z like that. It's more kind of not really the common type of Z, you know. So that one is like you're having a Z like this, you know, like this. Are you with me? So now this is what, as I said, this is what you come up with when you see these two parallel lines. So we call this AB and we call this CD. So how do we write it? We are saying A, B. If you indicate these parallel lines, we put a line that is like this, straight ones. AB is parallel to CD. That's what it means. So now a few things now you have to understand. Number one, there is what is called co-interior angles. Now the co-interior angles they are talking about, I'm gonna mark them. If I mark these angles that are inside here, you see that angle like this one and that angle like here. So those angles are said to be co-interior. So where do you find them? You find them inside the U. It is that angle and that angle. And as I said, we are calling them co-interior. There's a T there. Co-interior angles. Right. So it's co-interior angles. That sign they can represent angles. Okay. So now after that we have got these angles that are in the F. As I said, now look at the F. If I do that and I do that, so in here there will be on this part down there, and then there will be also on that part. We call them corresponding angles. So this side is called corresponding angles, right? And then the last one where there is the Z, which is you are having an angle that is here and here. See that? Now these are called alternate angles. It can be like that, or it can be here and inside here. See that? We call these guys alternate angles. So that is what I'm saying to say, whenever you are given parallel lines, remember three things: the F, the U, and the Z. The F is what? Corresponding angles. The U, co-interior because they are inside, and the Z is alternate angles. But in here, something is also special about these corresponding angles. What does it mean? Corresponding angles are equal. So it means if I had an angle, for example, this angle is X, even that angle is going to be X. That is what is special about corresponding angles. Also, alternate angles are equal. If I've got an angle here to be X, that angle also is going to be X. Even here, if this angle was Y, that angle is going to be Y. These are called alternate angles. But under co-interior angles, something is special. We say they are supplementary with a double P. They are supplementary. What does supplementary mean? Supplementary means they add up to 180 degrees. So every time you hear the word supplementary, just know that they add up to 180 degrees. So remember the thing I said in a straight line previously, where we talked about a straight line, to say angles in a straight line, if I draw a straight line, and then I said this sum of angles here in a straight line, so the angles in a straight line are also what? Are also supplementary, meaning they add up to 180 degrees. Okay, so now look at this activity. It's a quick one. It says find the value of the following. Number one, I hope these are clear to you. Number one, we're supposed to find here x, you see. Now just give me a thumbs up again if you're still following up. Thank you, sir. Now look at this. This is says find the value of x in the following. Now we have an angle, the way they did it here, there is this angle here which is 52 degrees, you can see that, and then there is that angle there which is x. So what did you say? You look at the straight line. There is my straight line, and we said sum of angles in a straight line add up to 180 degrees. So if I add that x plus the 52 degrees, I must get 180 degrees. What is the reason? Sum of angles in a what? In a straight line. I'm just writing it in brief. That is the reason why I'm saying that. Now, how do you find this this 180? Now, for me to find x, remember it's plus, I take 52 to the other side, then I'll have x. Okay, let me just check. Maybe if you can send me a message. Sorry about that. If you can just send me a message on the message tab, just to get sorry about that, Yanrick. Oh, you give me the answer. The answer is 128. Yes, man, you're right, because you're separating that. Okay, it's 52 blah 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 8. Yes, thank you for that. It's gonna be 128. All right, and then even on this other side, look at this other one here. If I'm saying find x here, you see that it's the same thing. What do you think if we are gonna find x there? So what you have here, you have got a 90 degrees there. Don't forget, this is 90. So you're going to say 90 plus x plus 38. You see, then it must give me what? 180 degrees. Okay, so that is also something that what I'm saying, that you must use there. So it's 90 plus x plus 38 degrees. But what you need to do now is to take 90 to the other side, take 38 to the other side, so that you're left with x. Then you can find that value of x there. All right, then even on this one, look, it's not really complicated, but they just split it here to say there is an x there, there is a 28 there, there is a 39 there, but the key thing is, look at this, this is a hidden 90 there. And what are we having? We are having a straight line. So what you need to do is to add the x plus the 28 plus the 39 plus the 90, and then what must you get? You must get 180 degrees. But what you do, you can add all this now, then after that take them to the other side, then you're going to be left with x. Then you solve that. All right, okay, let me just check. I think you're saying it's 23. Okay, so yes, so I didn't calculate that, but that's correct in approach. It's an acute angle like that. So this is how we, just as I'm saying, I'm introducing just a few things here, and the next part is angles in a circle. You'll see later, but something about a circle that you need to know is that when you talk about a circle, if I'm to say I'm rounding up a circle, that's why you hear say 360 degrees. So angles in a circle now, instead of a straight line, they add up to what? To 360 degrees. That's the thing that you need to know. The next one is the type of, let me erase this. It is the type of triangles. Here, on the type of triangles. Now, on the type of triangles, we have got, I'll say, 3 types or 4 types of triangles. Let's start with the first one. The first one that is common here is, okay, not really common, but let's say this side is equal to this side. What do you call this? We call this the isosceles triangle. Okay, this is the isosceles triangle. And then I can have another triangle whereby all the sides are equal. How do you indicate that? You indicate that by showing that this side is equal to this side is equal to this side, and this side is called an equilateral triangle. Equilateral triangle. And then you will have another triangle where sides are just different, you know, it doesn't matter which side, but this side, this triangle is called a scalene triangle, whereby all the sides are not equal. And then lastly, the fourth one, you have a what we just talked about, the 90 degrees. That's where now you have a right angle triangle, whereby this is 90 degrees and this is called a right angled triangle. We're going to do a lot about this triangle, a right angle triangle. We're going to do a lot about this. But now, when we talk about this part, angles now in a triangle, this is now important. I just want you to pay attention here. If we're having a triangle like this, if it doesn't matter whether it's isosceles, any triangle, whatever case. So let's say this angle, this is A, this is B, this is C. You must know that if I add angle A, which is that, and then I add plus angle B, and then plus angle C, I must get what? 180 degrees. Alright, so sum of angles in a triangle, they add up to 180 degrees. Secondly, you must just understand whenever they are naming the sides, if this is my A, opposite to the A is my small a, that is side BC, it's A. Again, opposite there is my small side B, opposite that is my small side C. That is the term, but it's not really important thing, but just know when you see small letters in a triangle, you must try to see those are sides, but they are usually named in terms of the letter that is in the angle. So if you've got angle A, this is referred as A. Alright, don't forget, sum of angles in a triangle, they add up to 180 degrees. And then we have got a triangle like this. If I draw a triangle, there is a triangle, and then I have a line that goes like that, and then we call this triangle A, B, C, and then this extends to D. Now look at this. If I say I have an angle outside here, this particular angle has a name. We call it the exterior angle of a triangle. This is the exterior. The keyword there is exterior angle. Don't forget that. Very, very important one. You need to know what it means. The exterior angle of a triangle. So that angle that is outside there, well, how do we name it? We call it angle ACD. So that's the exterior angle. Now it says this exterior angle, if I give you that angle and add them together, meaning if I say angle A plus angle B, it is equal to that angle ACD. You must remember that. So the exterior angle of a triangle is equal to the sum, you see, plus the sum of the two opposite interior angles. So if you look at a triangle, you look at the opposite angles that are inside. If you add those two triangles, it will be equal to the exterior angle of the triangle. Alright, so we'll do some activities. So it doesn't matter, I can draw a funny triangle like this, and then I do that, like that, and then I say this angle here, this exterior, is equal to that plus that. Are you with me? So that is the exterior angle of a triangle. So this is already out of the way because it's along the same line as the exterior angle. So it's the opposite angles that is more important there. So that is that. Let's look at a few things now that will make this make sense. Some activities again. Look at this. It says find the unknown angles in the diagrams below. So whenever you are looking at this is more of a circle. It's a point, you see. Why? Because you are starting from here. Let me make it visible. You are starting from here, you are rounding until you are back. So this is a circle, and we said sum of angles in a circle, they add up to what? To 360. So we are going to say 70 plus 110 plus 63 plus x See, I've added everything. They must give me what? 360. And then it is now, I'll ask you then to say, please calculate that, add everything there, and then take it to the other side, and then you'll be able to say what is the value of x there. Okay, you got the value of x for me. You are saying it's 117. Okay, thanks for that. Now, how about this one now? Try for me this one and tell me how you're gonna fare up this kind of an example. What do you think? What do you think will be the value of x? Try it on your side, and then I'm just gonna give you 2 minutes. Try it. Find me the value of x. Don't forget, there are two of them. There is x here, and then there is x there. Now, what do you think will be the answer in that case? Just to give you yeah. All right, let me just quickly check there. You are saying x is 45. All right, now let's look at this. Let's try to work it out together. If x is 45, I'm going to say I've got x plus 120,5 plus 149,5. We say this must give me 360, right? Then x plus x, I must get 2x. It will be equal to 360. I can add this, but I can take it so long that side 120,5, it becomes negative, minus 149,5. Now 2x is equal to, let me just work on that on my side and see what it gives me. Okay, so I've got 360 minus 120,5 minus 149,5, right, equal to 90. You're right. Divide that by 2. Perfect. You got 45. So if I divide 90 by 2 there, I get my x is equal to 45. Perfect. I'm 100% agreeing with you. So that is that simple activity there. Now look at this one. What will you say on these two? Now this is the key part. It says find the unknown angle, right? The first one, look at it, you are having a triangle. The second one, give yourself a bit of time, but if you can, it will be interesting just to check your knowledge there, to say what is the first x there, and then that is let's start with the first one. What is the value of x there? How will you approach this guy here? Just giving you, just a few seconds, not much, just to get it going, to say you are given x there, and we want to find the value of x. Alright, okay, so you got the first one. The value of x there is 35. Okay, so let's quickly do that. So what you have is x. If I take x plus 108 plus 37, remember this is a triangle. We said angles inside a triangle, they must give me what? 180. Then I think there to be x is equal to 180 minus, if I add those two, 8 plus this is 5, 3 plus this is 4. That's 145, which is, I think you're right there, that's 35. You're right. Perfect. Now what about the other one? What is x? What is y? Can you try that one? Just a little bit of two things that you need to use there, and it gives me a bit of encouragement that some of the stuff, the foundation of this geometry won't be as bad if you can pick up a few things there. You are having actually a good foundation there. If it's if you think it's a bit out of the line, just raise your hand. I will understand that it's off, and then if you're still working on it, you can continue. Right, so okay, is it I see, which means it's a raised hand, am I right? Must I go on and do it for you? Okay, all right, okay, thank you. Oh, I see now the messages are coming through. Thank you. All right, look at this. If we're looking at this one, man, it's a bit of first part, they didn't give you the y, they didn't give you the x, but we know that if we take 45, let me use a different pen here. If we take 45, we say 45 plus y plus x. You can see that that is a triangle now. It must give me what? 180 degrees. Unfortunately, we couldn't do this much. Why? Because we don't know x and we don't know y. So now then we need to go to the next stage. The next stage is this that was hidden from you. This line, angles in a straight line. You see? So that here is 109. Then you can first find y. So how do you find y? You are saying 109 plus y must give me also 180. What is this reason? Angles in a straight line. I mean not in a triangle, in a straight line, you know. Remember we said they add up to 180. Then you've got y. Take this to the other side. It will be y is equal to 180 minus 109. Then I think if you do that, you will get, is it 71? Let me just quickly check my calculator there. If you subtract 180 minus 109, it will give you 71. So you've got y being 71. Then you good with y. You come here where you say now 45 plus y is what? Is 71 plus x is equal to 180. You understand? I think you got that now. Thank you. So that is how the approach is now. So say at this stage, the keyword is they needed you to catch that. If you can catch that, then everything then after that follows. All right. So now let's continue. I'm impressed. I'm happy. Let's look at a few ones before we come to some exam kind of questions that you're expecting. Pythagoras theorem. The theorem of Pythagoras, I think you will see it. It's simple and basic. If you're looking at the theorem of Pythagoras, you need a 90-degree angle. Then if this is your A, this is your B, and this is your C, you must know what it says. Remember A, I said this side, if it's A, this is side A. If it's B, this is side B, and that is side C. So what does it say? It says the B squared, the longest side, is equal to C squared plus A squared. But this they give you, you don't need to worry about this. You are given this in the formula. The one that I want you to be careful on, that I'm kind of teaching in here, is this one, similarity and congruency. You need to know the difference. So now, what is the difference? What is similar? Similar, I can have a triangle like this, and then I'm gonna call that triangle A, B, and C, right? Please pay attention now. Then I can have a triangle like this. See that triangle? And then I will call this triangle X, Y, and Z. Now, if these triangles are similar, this is what I'm going to say. I'm going to say triangle A, B, C is what? Is similar to triangle X, Y, Z. Look at the sign I used. Look at how I wrote everything. It means triangle ABC is similar to triangle XYZ. Now, in similarities, please remember this. Similar means it looks similar. You know, just from the word, it looks similar. It means I can come up with a ratio. Now, if I say AB over BC, like this, Also, I can use the other side and say xy, because AB is like xy. So I'll say xy over yz. You see what I'm doing there? I can choose anything. If I say AB over, then I say xy, I have to choose xy because AB is similar to xy, you see? And then I can also say is equal to AC over, which is similar, xz. You see that? You play around similar things. These are called ratios. Why? Because these triangles are similar. Even if I didn't have these triangles, just from these letters, look at the way it is written. It's written A, B, C. This one is written X, Y, Z. So I can even come up with anything from here. It's A, B. See this A, B? So I can say A, B over and then X, Y. See? Is equal to, then I can say BC, BC over, and then I can say YZ. You see what's happening there? So it's you following the pattern. So remember, again, let me choose something different. If I say I've got triangle A, B, C, and then I've got triangle X, Y, Z. They are similar, remember? So look at this. If I say AC over AB, see what I did? I must follow suit on the other side. AC is like XZ over, and then it's what? XY. These are similarities. That's what you do when you're talking about similarity. Even in congruency, it works the same, but it's only common, especially when you deal with what? Similarities. We're going to use this. Now, let us go to congruency. What do we mean by congruency? Now, congruency is like this. If I have a diagram, a triangle like this, please pay attention. This is that. I've got a triangle like this. And then for congruency, look what I'm going to do. I'm going to duplicate this and pull it here. That is what congruency means. Congruency means identical. So if this was A, this was B, and this was C, this will also be A, this will be B. Even if it's XYZ, it doesn't matter. Let me call it XYZ. X, Y, and Z. Now, one thing for sure is this side must be equal to this side must be equal to this side, and this side must be equal to this side. That is congruency. That angle must be equal to this angle must be equal to that angle, and this angle must be equal to this angle. Congruency means identical. Similarity is it looks similar but use ratios. So now in congruency, there are different types of congruency that you're going to use. The first one, I'm just going to do them in brief. Of course, you can check your textbooks and everything, but there is the side, side, side. This is the first one where you're testing congruency, meaning all the three sides are similar to the other three sides of a triangle. That's number one. Number two, there is the side, angle, side. So here, sorry, side, not C. Then in here, what will be happening is you will have a triangle like this. I didn't want to waste time much here so that we can look at practical examples. But if it's side, angle, side, you have a triangle like this, and you have a similar one like this, right? And then if I say side, it will be side, and then there is an angle, and then there is a side. So even here, side, there is an angle, and there is a side. That's what it simple means. And then number three, you can have the angle, 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 where all the three angles are equal to the three angles of the other one. And then number four, you will have a triangle which is the 90 degrees, the hypotenuse, and the side. I'm going to demonstrate this. I think there is an example for you. There is a 90 degrees, which is right angle triangle, the hypotenuse, as well as a side. And then I think the fifth one will be side, 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 angle. So you have got the angle, side, angle. So look at it. Side, 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 angle, angle, angle. This can help you. And then side, angle, side, angle, side, angle. And then this other one then is the 90 degrees, the hypotenuse, and the side. This one is like this, whereby you are saying the 90 degrees is here for this part, and then you've got the hypotenuse as well as any other side, but I'm going to demonstrate that at a later stage. So this is what we mean by congruency. But now let's look at some practical questions. I think these things will make sense now. Here, look at this. It says, this is what I pulled in from a previous paper. It says, complete the following sentence by writing only the missing word or words next to the question number 6.1 in the answer book. Forget about that part, but let's look at this. It says, if the co-interior angles are supplementary. I repeat again. If the co-interior angles are supplementary, then the lines are, can you give me a guess? Maybe just put it on the text it back. What do you think? If you can maybe write the answer for me. If the co-interior angles are supplementary, now then the lines are, I'll take you back while you're writing there. Let me take you back to our lesson here where we had the lines. I hope we still have those lines. I don't know whether I removed them. I think I removed the lines. Unfortunately. But what they are saying here is, remember when you talked of parallel lines, we mentioned something about parallel lines. Let me come back here. We said for parallel lines, if they give you parallel lines like this, and then they must be like that, they must be like that. That's a co-interior, that's where you put a line like that. And let me do it like this. Co-interior, you do this. And where are the co-interior angles? This inner one, that angle inside is it, and that angle. We said when you add them, they must give you what? They must give you 180. We said they come from a U shape. That and that, we said they are supplementary. And then supplementary means they what? They add up to 180. But they are saying if the co-interior angles are supplementary, so you know that these, when you add them, is 180. Then they're saying the lines are, they're asking about these lines A, B, and CD. They are what? They are parallel. You see, it only co-interior angles happens in parallel lines. Okay, so that is the answer that they wanted to bring. Now, next one is, let's look at this picture here. It's a very big one. Not big one. It's a very good question to do our practice here. Look at this. I'm going to give you this question. We're just going to take a short break, 3 minutes, 4 minutes break, so that you can refresh also. Look at this. It says, study the diagram below. I will be also kind of interested to see you trying this one for me. Look at this. We'll be talking together, giving each other hints. It says, study the diagram below. Calculate the values of A, D, X, and Y. Listen now, and give a reason for each answer. So if they are saying A, B, C, A, B, X, Y is 4 marks. So 4 marks for the calculation. For every calculation, if you don't give a reason, unfortunately, you can only get, out of 8, you'll only get 4. So you must state the reasons. So what do you think? How will you calculate? Okay, just for interest sake, you calculate for me, and then I will also now work towards the reasoning with you. Just calculate for me A, B, X, and Y. What do you think then? It's 8 marks. These are good marks. Alright, any idea? Just to check on your answers. Okay, so you're saying, I think I was missing that inside the triangle is 47. B is a straight line. Okay, it's 133. X is in a straight line. Okay, that is coming well. So you're saying number 1, A. Okay, inside the triangle is 47. And then B is a straight line, so which means here A, you are saying is 47. Okay, let's check that. So what we say, let me see your reasoning there, saying A inside of a triangle. All right, that's correct. That's correct. To say inside of a triangle, you still get your mark. And then so what you do is this is how you to make sure that you get your marks properly. You do this. You say 55 plus, and then you say A. Okay, this is, and then plus 78 degrees is equal to 180 degrees, and then you put a bracket and then you say sum of angles in a triangle. See that? That's the reason that they will give you marks, that one. Then they will mark that. Then from there, as you say, you're going to say A is 180 degrees minus 55 minus 78. And then if we are saying that, let me just check what was the answer there. With the calculator I have is 180 minus 55 minus 78. It gives me 47. Okay, so this is 47 degrees. So you come here and say this is 47 degrees. So you have also 47. Perfect. So now let's continue on this one. So I've got 47. Now if I want to find x here, so what is x? I'll say x plus 78 degrees is equal to 180 degrees. You know what do I call that? Again, reason, please don't forget putting the reason. Put a bracket, angles in a straight line. See, and then from there, what is that? X is equal to 180 minus 78, and then it will give you what answer did you get there? Just to check, it's 180 minus 78. I think you got this one. It's 102. So this x is 102 degrees. Let's check on that. X is 102. Perfect. And then let's look at the other one. Similarly, on this one, you use same method. Y plus 55 is equal to 180 degrees, and then reason angles in a straight line. I know my writing is terrible, man. Apologies. I'm using left hand. It's like I'm hanging on a tree sometimes the way I'm writing. So apologies for that. So then you take that there. So you've got y is equal to, it will be 180 minus what? Minus 55 there. Alright, then you get 125 here. 125 degrees. So let's check that your y is 125. Thank you. Then you come back to B, and now, and again, there are two things just wanna have with you here. B and x. Someone could have approached x, this 102. Someone can approach it differently to say, you see x here, but you still get your same answer. X is exterior angle of a triangle. I can add a plus what? Plus that. You see that? So if a, we said a was what? 47. So you can say x is equal to 55 plus 47. And then you say what? Exterior angle of a triangle equal to sum of interior opposite angles. That's also fine. So that you say 45 plus that 55, 55 plus 40 plus 47 there. I think it must give us what? Let me just try. 55 plus 47, it gives you what? 102. You see that? Similarly, B was same as a straight line. You're going to say 47 plus B is equal to 180. You get B, or you can use B to say that B is 55 plus 78. It will still give the same answer. Okay, so depending on that, so this the here when you say B is equal to 55 plus 48, the reason is this one. You understand? Then here, if you say that these are angles in a straight line, if you are using this one, so that is that, man. But I'm impressed. I'm happy with the way you approach them. Now look at this. These now are what? It says state the case of congruency represented by each of the following. Do you want to give it a try there? I gave 3 types. Let me see the congruence that we did. These. Remember, when you're talking about congruency, I said there were 5 types: side, 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 angle, side, 90 degrees hypotenuse side, and this one. So now here, what they are asking, what will be your take? what types of congruency do you think will be? Just a sec, I'm giving you just a minute, then we can do that together. Okay, but fine, let me work on that. I think sometimes it doesn't, this sound keeps quiet. So the first one, you're saying side, angle, side. Right, let's look at this one. You're right, there is a side, there is an angle, there is a side. You're right there, side, angle, side here. And then this one, look at it, they are giving you this kind. There it is. The moment you see a right angle, you must know what it means. So there is that, and then they are giving you the other one similarly, like that. See that? So what we have is the 90 degrees on both, and then hypotenuse, the longest side, and then you have got one is 90 degrees hypotenuse, and then you have got this common side. You see, they are sharing that side. So this is the type of congruency. It's called 90 degrees hypotenuse side. Are you with me? So that is the other type of congruency that you could have done there. All right. Now there is another one. Try it for me. It says you are given triangle KMN with KN extended to P, MN extended to O, M is being 55 degrees and angle N4. You must be able to say N4 there being 67 degrees. Then it says calculate the value of X and Y. Give reasons for the answers. They just made it 4 marks. What do you think will be the answer there? Calculate the values of X and Y. Let me just indicate the X there. Can you try that for me also? There is the X and there is the Y. And then if you can just do that, and then we see what it gives. Okay, you're saying y1 is 113. Okay, let's continue. All right, continue there. If y1 you're saying is 1, all right, and then with reasons, what will be the reason there for y1? Okay, y2 is 67. All right, just give me the reason for y1, because the question here said we need to calculate x, y. Okay, that is the y1 there. Just the, yeah, you're just calculating this one. This one is fine. That is the values of x and the value of x and y. They don't, I don't think they needed this, but I understand what they're saying. Just in case, you know, they were not just clear there. Yes, but y2 is 67. You're right there. If you had to take that to become y2, you're right. But the way it is, they did it like this. This is actually n, the n. So this represents n. So it's n1, n2, n3, n4. So y is n1. See, so like y is our n1. So it's the n that is belonging to the numbers. So in this case, you are correct about this one. But as you said, these are sum of angles in a straight line. And I like that you picked that up to say this is a straight line. So what you did, you said 108, what did you say here? Y plus 67 is equal to 180 degrees. Then take this to the other side. Then you've got y is equal to 180 degrees minus 67. So that you have got your y is equal to, I'm not good with mental subtraction. Let me just take a calculator there. It's 180 minus 67. You get 113. All right. So this is what you got on this side. That was perfect. Now, x is 58 degrees angles in a triangle. Let's look at x. Now, oh, now I see. Okay. So you used this part to say here, so we know that this is 113. Okay, I'm going to use the other version. So this is 113. I'm going to use this version on my side. I'm going to take this one. I see what you used. You used 62. You had 62 here. So you say this plus that. It must be 180. And then let's confirm it together like this. And then I'm going to use angles You see this being angles, exterior angle is equal to this plus this. So meaning x plus 55 is equal to 113. Meaning the exterior angle of this triangle is this one is equal to the sum of these two guys. You see that? So my x then will be equal to 113, and then take this to the other side, it will be minus 55. So what is my x there? It will be, in this case, if I can just take that, is 113 minus 55, and then 58, which matches what you have. So but what you did is 100% correct. Just know that I would have gone for the same one. So it's the same same approach. But here, if I'm to give a reason, remember they said I must give a reason. This is the exterior angle of a triangle. That's the reason, exterior angle of a triangle. That's why I'm doing what I'm doing. Okay, so now what I want us to do, okay, let me see if I think this is the last one. I want to give a short break. Okay, let's do this, man. Let's take a short break, just 5 minutes break, just to give yourself a refresher, and then we're gonna do a few of these again. We do this question 6.3, and then we'll look at another one here, question 6 here. Let me look at this. We'll also look at this one, but let me just give you just 5 minutes just to refresh, give yourself a breath, and then we'll come back again and we'll work on this again. All right, just give yourself 5 minutes, just 5 minutes. All right, welcome back. Let's continue this part. Let me give you my screen. Thank you if you are still there. Let me share with you my screen again. Okay, give me a thumbs up again if you are connected to my screen, if you can see my screen. Thank you. Now look at this. Now it says here 6.3. yes, we're just looking at the other one there. 6.3 says given triangle ABC, you see that means similar to triangle AEF, with EF parallel to BC. There is these two lines, EF parallel to BC, and what they've done is just that they are not clear, but these are the lines that they are trying to show there. Now calculate the value of x, and then how many marks is this? This is 2 marks, but we want to calculate the value of x. Similarity is the one I said what you need to do is to use triangles. So what you do is you can take this triangle out, this one here. I know you could have done it, but let me just quickly move on to the next thing. I want us to quickly move to trigonometry. That's why I'm just doing this. So you've got your A, and then your E, you see, AEF is there, and then you've got our A, B, and C. So now look, that's where I've got X here being AF, and then in this A, okay, this is 5. Now look at AB, it's 20 plus 5, which is 25. You just need to be careful like that. So you need a complete side. Look at this side is comparable to this side. So if I say to you AE over, that's why you use ratios, AB. Why am I taking that? Because I'll say 5 over 25 is equal to, there is my X, you see the X there, I'll say AF, which is what I want to find, over, it must be AC. But now what is AC? AC is X plus 18. See that? You see that? That's my AC. You have to add FC, which is 18, and then AF, which is what? Which is X. So now I can then go on to calculate that. Meaning AE was what? It was 5 over AB was what? 25. See that? Is equal to AF, and then AF we said was X over, and then AC, which is X plus 18. So this is the congruency part that they wanted here. Let me just pull this down. This is what they wanted you to solve. Now how do you solve this? When you're solving this, you cross multiply. The top multiplies the bottom, the top multiplies the bottom. So what you have is X times 25, which is 25x, is equal to 5. Now look, 5 times x plus 18. Now because it's x plus 18, you need to put a bracket there so that the 5 will go inside and the 5 will go inside. Be careful for that. So you're going to say 25x is equal to 5 times x is 5x, and then 5 times 18, 5 times 8, I think it's plus 40, which is 0, 4, then becomes 90. But you can just quickly verify that without much of a hassle. I think it will be 9 degrees. Alright, and then let me just check on that. Sorry about this. Alright, so okay, thank you, sir. And then so what we have now, and I say 5 over 25, you do this, and then say 25 is equal to 5x plus 90. Are you with me, man? Are you following? Just give me a thumbs up if you are. Thank you. So now what you do, take 25x that side, so it will be 25x minus 5x is equal to 90, right? Then what you do is you subtract this 20x. I hope this 90, I got it right there. Then you divide. Look, I have to find x now, so the only thing to do there is to divide by 20. Alright, divide by 20. So I'm interested in the method, not really the answer, but you can then see that it was what, 4,5. But now you come back to say x is 4,5. What unit is in millimeters, you see? So it's 4,5 millimeters there. So understand I might have made an error there, but check the method. What is important is this step here. This step, this is the one that is important. From here and then coming up with this step, that is the most important one. So don't forget, similarity is taking similar triangles. If you say AE over AB, you must maintain 5 and 25, and then on the other side AF over AC, you must also maintain that. Alright, okay, answer for question for Q is x is 6. Let me just check that. Am I missing out something there? Okay, let me look at just on this one. Did I miss out anything? Okay, let me just check this with you while we are talking of that. Let me say is what is 5 times 18. Okay, and then you're saying okay, 25. What do we say? 25 here minus 5x, and then is what we're saying what is 90 divided by 20, and then is that okay? Just come back to me again. I think I might have missed out something. You are saying the answer for question is 6. Okay, so x is 6. Okay, I'm getting something a bit different there. I'm getting something a bit. I wish we could communicate, you know, on the part of the, as you said, part of the mic. Unfortunately, sorry about that, but I hope you are going to be able to express this for me and then just to communicate on that. But just give me like do this for me. As we said, you can connect with me either on an email and everything. If you feel like there's something that was not done right here, we can also refresh it tomorrow, right? I'll put a question mark here. If you feel like the answer was, I think you said x was equal to 6. If you want to get more clarity, remind me again so that we can work on this again. Am I right? Okay, the answer for x 6.63 is 20, not okay, saying the answer for the x, okay, 6.3 is 20, not 25. Okay, let me just check that. 6.3 okay is 20, oh, not 25. Okay, look at this, man, look at this. Now I see what you're saying. Look at this. Now what is my A. Look at this. I want to show you something here. I get it what you're saying now. Look at this distance here. Look at this. What is the distance from here to here? Which is the distance from here to here. You see that? Now what they did was the 20. Let's look at the question that they didn't do anything on the question, but the way they did it, they are saying from here, when they write it like this, from just that things are not drawn to scale, you know, from here to here, that is their 20, and then from here to here is their 5. Just like from here to here is their what? Is their X, and then from here to here, now okay, then from here there is their 18. So now, okay, let me just check what you're saying there. Oh, so you did it to 20 to find the X. Okay, I understand. But now I hope you get it to say you had now to add now to say 20 plus 5. You see, it's making this 25. Okay, 100%. So okay, so thanks for that, for picking up that. So it is a matter, what they wanted to do was to kind of trick students into thinking, yeah, as you're saying, the trick part was to say this side AB was 20, so the side AB is actually 20 plus 5. Okay, all right, so now that is that part. And then let me see if ever there's other things coming in. All right, this is the question now that will wrap up everything here. It says complete the following sentences by writing only the missing word or words next to the question number that and that. It says lines that intersect at 90 degrees are, so like look at this, if they say they intersect lines, I can draw a line like this, I can draw a line like that. If they intersect at 90 degrees, these two lines, if this is AB and this is CD, we call these lines perpendicular. Okay, these are perpendicular lines. All right, perpendicular lines. Why? Because they meet, or intersect means they cross each other there. They cross each other at what? At 90 degrees. That's the first one. The second one says an angle that is formed outside a closed shape between the side of the shape and the side that has an extended is N. I think here they were just trying to make things too long for nothing here. They're saying an angle that is formed, the keyword there is an angle that is formed outside a closed shape. So the key part is like this, man. I can close a shape. This is what they wanted to bring. I can do that. You see, this is a closed, and then the angle that is formed outside is this, whereby you form an angle like this. It can be even a square, doesn't matter, like this, and then when I close and form an angle like that, what do we call these angles? We call them the exterior angles. Are you with me? So that angle is called what? Is extended, is an exterior angle. Alright, so that is the answer that they wanted to put in there to show you that is that. Okay, 6.2, look at this. Find the values of A, B, C, and D. As I said, I would have loved you to do this, but because of time, because I need to do a bit of trick there, trigonometry. Let's look at this. Let's do this together, and then you can always refresh. It's 8 marks, man. First things first. Find the values of A, B, C, and D. Work with what you know. First things first. Look at what they have given us, and they have given us this. That's the first part. And secondly, they are giving us these arrows, meaning they are parallel lines. That's what they are saying here. And they have given us this one, and they have given us this one. So now, to give us that these lines in a way they are parallel, so what they have given us, look at this straight line. So meaning, if I can take this angle and take that angle, these are angles in a straight line. If I can say A plus 20 plus 2A plus 10, it must give me what? 180 degrees. And then reason here is angles in a straight line. Okay, so we did that. Now collect like terms. A plus 2a is what? Is 3a, is equal to 180 degrees. Now 20 plus 10 is 30, so it will be minus 30. Okay, then after that you can find now your a, which is 3a is equal to 150 over 3 over 3, and then which means my a here is what? Is 50 degrees. Right, so I've got my a being equal to 50 degrees. So now which means this angle, now I will know what is this angle. It's 50 because it's a plus 20. 50 plus this angle is 70 degrees, and then that is okay, that one is fine for now, 70 degrees. And then they made something important here. Let me just erase whatever I've been writing. So we know that this is here is 70 degrees. Now the moment they do parallel lines, don't forget parallel lines, look at the z alternate angles. You have this line, have this line, and have this line. It means this angle is equal to that angle. So D is equal to 2a plus 10. But you know what is my a? We said a is 50. So D is equal to 2a, which is 2 times 50, plus 10, which is D is equal to 2 times 50 is 100, which is 110. So here is 110. Okay, I think already you've been picking up. Thank you sir, you've been picking up something there. And then also when you've gotten that, look at this, I can find another z here. Can do it like this. If I can do it with a different one, to say I've got a line here, see that, and then my f, actually I need f, look at the f, there is my f, parallel. So what does it mean? It means in here, this and this, they are co-interior. That is one thing. Or this one is equal to that one. So I can say actually C is equal to E. What is it? The reason being corresponding angles. See, they are in an F. And then the other one, interior ones that are in a U, which is E plus B is equal to what? 180 degrees. These are co-interior angles. All right. But now at the same time, if I can, what can I have? If I can look at these, I'm trying to see here, I've got the 120 there, and then what I can have, so it's okay, it's just that I can't twist this shape, but let me try to show you this. Okay, let me not erase this part here. I just want to erase here. Let's leave that because I need to find one of them here between E, B, and C. But I can use this line now. Look at this. If I can have my F like this, I can twist it like this and like this. You see? So you'll see that this line and that is equal. You see that? So now it means if my 2a plus this is 110, which is my D here 110, it means also here it's 110. Why? These are let me just check. You're saying C 70 opposite angles. So yes, you're right. C there becomes 70 degrees. You are right, which is similar to that, which is 70 degrees, and then automatically E also becomes 70 degrees. You understand? But they did just that, they didn't say with reasons, so you can actually work this. Even if you don't put any reasons, they won't penalize you, but it's always good whenever you're working to put in the reasons. So there is the C, there is the B, there is the A, there is the D, and there is the E. And then the E, as we said, E is equal to C, and then E plus B must give us 180, which is that. Okay, so now having done that, let's look at a bit of trigonometry here, and then understanding a few things about trig. It says understanding the triangle, and on this part of trig on the triangle, I said SOHCAHTOA, Why do I call that? Look at it. If I give you a triangle, by the way, we are going to be working, whenever you're working on these, you're working with right angle triangles. So these are the triangles that you're working on. They must have a 90 degrees. So if I give you A, I give you B, and I give you C. Now remember this. As I said previously, this is your small b, this is your small a, this is your small c. So now when we're talking about SOHCAHTOA, S stands for sine. So if I say sine theta, and then C, so that is your SO, yes, SO, and then CA, it's cos theta, and then TOA, it's tan theta. Now if I come here and make that become theta, now what you need to know is the labeling of these triangles. Now look at this. The moment I put theta, this theta is looking at that angle. But okay, before that I can actually say, look at this 90 degrees and look at this theta and look at this line. So this line has got two angles. It has got the 90, it has got the theta. That line is always called the adjacent line. So this is the adjacent, and then the other line where theta is looking at is called the opposite side. We call it op for opposite. And then the longest one is called the hypotenuse. Alright, so now if I'm talking about sine theta here, it's back to say, what is sine theta? You can see SO, meaning S, O, actually it's S, O, and then do this H. So sine theta is O over H, meaning opposite over hype. You see that? And then what about cos theta? This is CA. You put a division line there. Cos theta is adjacent over hypotenuse. And what about tan theta? You put a division line there. It's op over adjacent. Please always remember this. But do you have to cram it? Not really, because I'll show you where they give you actually that. But I wanted you to understand this. Now, I even said understanding trigonometry in terms of x, y, and r. Now, listen to this. The opposite is always called, this is always called y. And then the adjacent is always called the x. So let me make it, so this is the y, and this is the x. Always remember. And r is the hypotenuse. So if I say opposite, it's y, over hypotenuse, it's r. Cos adjacent is x, okay, over hypotenuse is r, and then tan, it's y over x. This is two different ways you can represent that. Are you with me? And then after that, we're going to look then at the trig graphs, but because of time, I think we'll do the trig graphs tomorrow. Now look at this question. I approach this from a question so that it will make a bit of sense. By the way, this is what you find in your formulas. You see, they give you right angle triangle, then they give you the Pythagoras theorem, they give the theorem of Pythagoras, and then after that they give you these ratios to say sine theta is A over C. Now I want us to look at this. Why did they say A over C? So if I write here SOHCAHTOA, let's bring in SOHCAHTOA. Now we have got sine theta. Look at the theta. There is the theta. So you have to identify, as I said, which one is the adjacent side. Look at this line. It has got two angles. It has got theta and the 90. And I said that line is called the adjacent. So the adjacent is B. And then the other one automatically becomes the opposite. And the other one becomes the hypotenuse. Right. So now if they say sine theta, now sine is, see, sine is equal to O over H. Now which one is the O? It's A. See, A over H. Hypotenuse is C. That's how they're getting that. Cos is B. There is B there adjacent, which is cos is equal to A over H, and our adjacent is B, and then our H is C, and then 10 is like that. So I'm trying to say you don't need to cram it, but you can use that knowledge. Now look at this question. It says if tan beta is equal to 6 over 8, and beta is an element from 0 to 90 degrees. Determine the following. Now I just want you to pay attention here. How do you deal with this? That's when I was saying writing it in terms of x. See the statement here, understanding trig in terms of x, y, and r, and we are talking about this line here, this. All right, so what am I saying there? This is what you do. You mustn't panic on this one. You are saying tan b, they just gave you that. So what you do, I will encourage, is to say tan theta in general is equal to, remember, SOHCAHTOA, you identify again to say so, ka, and then toya, and then you say, remember, tan is opposite over adjacent. You remind yourself of that. Now when you do that, they gave you though the tan, they told you that tan beta, you compare now to say my tan beta is equal to 6 over 8. So which means my opposite is 6, my adjacent is 8. But I say it again here, how do you know with opposite? The opposite is represented by y, and then the adjacent is represented by x. You need to remember that. So you must always have that to say opposite is my y, adjacent is my x. So here you're going to have now to say x. Let me write here. You say tan is y, opposite over adjacent, which is x. So do you see what is your y? Your y is equal to 6. Your x is equal to what? 8. Now guess what? You can find your r. How do you find your r? That's why they gave you this statement as the Pythagoras theorem. Here they gave it together with this. So you're going to use the Pythagoras here to say r squared is equal to x squared plus y squared, because this happens in a right angle triangle. So you've got r squared is equal to x squared is 8 squared plus y squared is 6 squared. This is what you do before you answer any questions. Always do that. And then after that you have got r squared is equal to, and then when you add that, let me just check. I think you got some answer for me. The answer is 10. Okay, I think you're saying the answer is 10 there. All right, so which means I think you're saying it's 100. I square root both sides, and then r is 10. Thank you. So now, since I know that my r in here is equal to 10, so what we do, let me take this off. Look at this now. When you start answering this question, sine beta cos beta plus tan beta. So what you do, we are saying sine beta cos beta plus tan beta. So what you do here is how many marks? They gave it 4 marks. So what you do is you say, okay, what is my sine? You back to your SOHCAHTOA. See, sine is O over H. So here you can say sine is O. I'm just going to write it in brief here. It's O over H. Cos is A over H. Tan is O over what? Over adjacent, over A. Now we said O is Y over hypotenuse is R. You see, that is sine times cos, adjacent is X over R, plus tan is Y over X. You see what we're doing there? So you are now substituting. So where there is Y, what are you going to have? Y is 6 over 10 multiplied by X, which is 8 over 10 plus Y, which is what? And then which is your 6 over 8. That's how you solve this guy here. Then you get the answer. All right. And then the next one says you need to solve this. 4 plus sine 90 plus sine squared plus cos squared beta. So sine squared plus cos squared. Again, you need not to panic there. Just want to work out. Okay, let's work it out separate. 4 plus sine 90. So this is what you do. You're going to say 4 plus sine 90. I think it was saying plus sine squared beta plus cos squared beta. Right, so look at this. Let me just give it yes. Now when they give you this cos squared, you mustn't panic again, it's not something complicated. So 4, you say 4 plus sine 90, you use a calculator, and then it must give you what is sine 90. So if you say sine 90 equal to, it gives you a 1. So 4 plus 1 plus now sine squared. Look how you do. Just like you did sine, we said sine was y over r. This is what you say, bracket y over r squared. See that? Plus cos, it will be x over r squared. You see that? Because that's how the squared is. The squared is actually outside when you put numbers. Alright, so which is 4 plus 1. Now what is the y? The y was 6, remember, over 10, and then you square it, plus 8 over 10, you square it. But I just want to show you something interesting about these two. Look at this. These two guys here. These two guys here. If I take a calculator and add actually what they gave me there, to say bracket 6 over 10, and then I say what? I say squared plus, you'll see something interesting there, fraction, it's 8 over 10 what? Again squared. What am I getting? You see, it gives you 1, because sine squared b plus cos squared b is equal to 1. So this is simple, 4 plus 1 plus 1, and the answer is 6. Alright, that's what they wanted to do there on this one. So in a way, already this is equal to 1, but you have to work it out. And then the other one says sketch the graph of this. We will do the sketching of graphs tomorrow. Alright, and then in a way we are just wrapping this up. As I said, we'll do the sketching tomorrow. Look at question number 7. It's another question that is common. Says the illustration shows a ladder that leans against a tree. So you can see a ladder there. Then says calculate the length of the ladder if the angle of elevation from the foot of the ladder to the top of the ladder is 49 degrees, and the top of the ladder is what? Is 5,283 meters from the ground level. So what they do is, look at this. They are giving you, let me use something visible. This is what we have. Then you have a ground, and then you've got that. So that's a triangle that you need to come up with there. So what you do is have that triangle like this, like that, like that. And then in that triangle, the ground is always 90 degrees. And then they're saying here it's 5,283. And then they gave you that angle being what? 49 degrees. Guess what? So always have it ready, car, Toya. So what you do is you need to now to label the sides, which one is what. And then I said if you are given that angle, so this line here becomes your A, your adjacent side. And then this one becomes your H, and this one becomes your opposite. I hope you agree with me. So this is my adjacent side, this is my hypotenuse side, and this is my opposite side. So when I've done that, I ask myself, what is it that they are requiring? The question says calculate the length of the ladder. So they want me to find here H, the length. How long is this ladder? So if they want me to find H, look, this one is out because it doesn't have H. So the H can be from these two guys. Now the next question I'm asking myself, what did they give me? See, I have a side O. So this guy is out, there it remains. So I'm going to say sine theta is equal to O over H. Now sine theta is 49 is equal to my O is what? 5,283 over the hypotenuse is what I'm looking for, which you can call it H there, because you are looking for the hypotenuse. Now how do you solve for X here? It's up to you how you want to do it, but you put over 1 here, and then you cross multiply. The hypotenuse multiplies the top there, the 1 multiplies the top there. So when you multiply, you're going to say hypotenuse times sine 49 is equal to 1 times 5,283. You see that? And then remember, you're looking for the hypotenuse. You divide by sine 49 here, and then when you do that, you'll get the h for the hypotenuse, which will be what? Sine 49. It will be 5,283 over sine 49. See, then when you do that, you get the length of the ladder is 7,000, almost 7. So it's 7. I think the units were in meters there. They were in meters, so that part there is 7 meters. But please don't forget, the key part here is don't let sight of this guy. In as much as they gave you those formulas, but if you get sight of SOHCAHTOA, that is the one that is going to be giving you a way of approaching this kind of questions. Alright, I hope it does make a bit of sense. Let me look at the next one, the last one here. We're not going to do the graphs as I said, but look at this one. It says simplify without a calculator by using special angles. Now be careful there. Then they give you this one. Remember, you must use special angles. Then say sine 45 times tan 30. Now I don't have, unfortunately, my formulas for the special angles, but if you check the formulas, I think I'll do this tomorrow. Let's work on this tomorrow, whereby I'll bring the formulas which have got the special angles, and usually they bring them like this on your formulas. What they will do, I think they'll give a 90, and then they'll give a 1 there, if I'm not mistaken, and then they give a square root of 2 and a square root of 2, and then here they give a 90, they give a 30, and then here they give a square root of 3, here they give a 2, I think here they give a 1, but we must check first. There are 2 special angles, and then that's when I'm going to also do that, but I don't think it's a complicated one. But this kind of wraps up our session, and then we're going to look at the graph sketching. It's not difficult. Also, from the level of what you have been interacting with me, I'm so much happy with your maths. It's solid to me. You just need a little bit there, and of course some errors are always bound to happen. But if you continue with this, use a lot of videos, use a lot of your textbook, look previous papers, then you're gonna be in a good position to get your good marks in there. So where are we in this case? If I can take you back to the beginning of this, just me going back. We're here now. You see, we did geometry in full, and then we did trig, but question mark there. We didn't finish that. We're going to do just a little bit of graphs here, and then finish that outstanding question. And then we're also going to look at conversions, percentages, mensuration, and some of these are word problems, kind of that, then that is going to be tomorrow. So please also bring in some questions already tomorrow. I know you missed some lessons already, so it will be a good time for you to either write some questions, send a picture to the 24-minute lesson, that Gmail that sent you the link. Send a picture of that. It's easier, to write questions down, take a pic and send. And then I will also consider that between tomorrow and Sunday to kind of give you feedback, and then we work them together. Says let's put it in there, let's work it together. It can be anything from this, because tomorrow when we finish up, then the assumption now is you are in a position to do anything. Now for the lessons that you missed, guys, unfortunately nothing I can do. I will encourage you have to check those videos, because it won't be possible to return to those. But the videos like this session is already being recorded. I will upload it, send you the link, so if you want to recap on it, you can always check it back. Now talk to me. I don't know if ever you are just to ask you to say, are you okay? See the message. Okay, thank you so much for your time. All right, thank you. Say I'm not tomorrow here because I'm playing rugby. Oh, you're going to be in Springs, man. That's